While finding derivatives by hand may be a lot of fun, it's nice sometimes to have technology to use to do the hard work for you. So in this video, what I'm going to do is introduce how to visualize a derivative in Desmos. And that's really all you can do with Desmos and calculus is a quick graph of what the derivative looks like along with the function. And then you can do a lot more with Python, and so this will introduce you to defining function and then also finding a derivative and plotting the function and the derivative together within Python using the sympy package. If all that you'd like to do is visualize a graph of the derivative of a function, then you can do that in Desmos. So let's start with defining a function in Desmos. If I come into one of the cells here, I can type f of x equals, let's say, x squared. And it will plot the parabola nicely over here on the screen. If you're not familiar with the tools, you can go into the settings and you can adjust the limits of the x-axis and y-axis to visualize just what you're looking for on the graph. But we have a function, and here is the graph of that function. Now, if you want the derivative of this function plotted as well, you can do that using the notation that we've been using in class for taking derivatives. So if I do dx f of x, it now plots the derivative of that function on the graph along with the function that was there. So we can see the x squared is a parabola, and then the derivative of this, which we can't see the symbolic expression written out here, but we can see that it gives us a straight line. If I change the function, let's make this a cubic, then the derivative becomes a quadratic, right? And so it has no problem taking the derivatives of various functions. We can make these more complicated if we'd like. So let's make this x cubed. I'll make it minus x divided by, let's say, the square root of x. Okay, because now we've introduced the square root function, the domain is restricted to just be positive values. The red curve is the function, so it's sort of like this truncated, almost looking like a parabola, but it's truncated, and then the blue line is its derivative. So if you want to visualize the derivative, then you can do that in Desmos without much problem. I've done the derivative by writing d by dx. You can also do that using the prime notation that is a little bit more compact. So if I just change this to f prime of x, it also knows that that's the derivative. So in a nutshell, if you're just looking to see what does the derivative of this look like, then come to Desmos, plug in the function, and use f prime of x or d by dx of f of x, and you can get a nice visualization of the derivative. I've set up here a notebook in Google Colab for showing how to use Python to do calculus, and the first section will be on functions, defining a function. There is a basic way to define functions in Python, and I can write it like this: def f of x, and then when I hit enter, type return, and then tell it what I want it to return. So in this case, let's do x squared. Okay, so I've created the function now that is f of x equals x squared. So def stands for define, and then the syntax is to put the name of the function, which you can call anything you'd like, and then in parentheses you put the variable that you're going to use, whatever the input is going to be, and then colon. When you hit enter, you'll notice that it's tabbed in, and that's important syntax. If you have the return over here, it won't work. You need to have the return right here, tabbed in, and then it'll tell you, then you tell it what you want it to return. In this case, we'll take whatever the input is and square it. Alright, so let's run that function, and let's check it out. So now that I have the function, I can evaluate f of 2. Now, let me mention that this would work no matter what you called f. You could call f function instead of just f, and you could call x variable instead of just x. The only thing you'll have to do next is change the name down here so that it matches. So now we have define this function called function, which takes whatever we put in here and squares it. So just to show that that still works, now my function is named function, and I want function of 2. Again, we get 4. If I try function of 3, we get 9. Alright, so this is the basic way to define a function in Python. Now, for doing calculus, we'd like to have all of the tools that are available in the symbolic Python library. So let's import that, sympy as sp. And then we can use this to define a function in a slightly different way. So we'll start with telling it what the variable is, and this is symbolic Python. The variables are symbols, and so we're going to tell it that this is a symbol. So this establishes that x is a symbol, and then we can write in what the function is. The function is going to be x squared. Okay, so the function f is x squared. So let's run this. Nothing prints out because I haven't asked it to print anything out. I'm just defining here x is the symbol, and then f is this expression here, x squared. Now, once I've set this up, I can see what it prints out if I type in f. Okay, and in a neat way, in a neatly fashion, it prints out x squared. So I have f, I have an expression that involves x, which is defined as a symbol, and then we can use that function to find the derivative and put it into other calculations. Alright, let's see how to use Python, and specifically sympy within Python, to find a derivative. So earlier we established the function, and the function in this case is x squared, and now let's find its derivative. So the function within sympy is sp.diff, and now we can take the differential, we can differentiate whatever function we want. So let's just do sp.diff of f, and it will tell us that it's 2x. We can also specify the variable, and that's a good practice here. If we do comma x, it gives us the same answer, but when you get to more advanced applications and you have functions that are functions of multiple variables, you will need to specify which variable you're telling it to differentiate. So although we didn't need it here, it is good practice to do the comma, then which variable you're taking the derivative with respect to. You know, it's d by d what. So in this case, there's only one variable, and the only choice is x. We can set this equal to a new function, call it f prime. I might call it df, but that gets confusing because df is a common way to notate a data frame. So I'll use f prime for my derivative of f here, and then if you want, so if I run this cell, it will just assign f prime to be equal to 2x. If I want it to then print out, I can ask for f prime afterwards, and it will give me the derivative. Okay, so this one was simple. We didn't really need to use the Python to find the derivative of x squared. Let's do one where you would need the quotient rule. So let's define a new function to be some type of complicated quotient. So let's make it x cubed minus x divided by, let's say, x plus 1. Okay, so we have a function here where we would need the quotient rule in order to solve it. We could use the chain rule as well. But we don't need to use either. Let's see what this looks like in the code format. Okay, so x cubed minus x over x plus 1. And now let's find its derivative. G prime equals, and you'll notice the AI has already kind of guessed what I wanted to do, right? It's saying do sp.diff g of x, g comma x, and then print out g prime. That is exactly what I want to do, so I'm just going to hit tab, and it will enter all that code, and I can run it, and it did the derivative for me in a millisecond. Okay. Now one more thing I'll show you that you might like to do with derivatives is graph them, and that's also pretty easy to do when you have sympy. You do need to add just one additional package, and the one you need to add is within sympy, so it's from sympy, and it's part of the plotting library within sympy, and we're going to import just the basic plot function here. So it's asking me if I want to do plot 3D. I could import any of these options. I'm just going to deal with the basic plot here. Okay. And because that's all I need. Now, the syntax for this is pretty simple. It's just plot, and I could plot either of the functions that we've looked at, but I'll do g and g prime. Okay, so I've done those two functions, and let's see what it looks like. Okay, there we have it. There's our function. It has chosen some arbitrary limits here to show. Those are all customizable. I don't want to get into all of the different options you can use to plot. You can make these things look really fancy and nice. We can save that for another video later. But what we have is a picture of the function and its derivative done very, very quickly. And you can use that for this function g, or we could replace this with f to see what f looks like. And there we have our function, the x squared parabola, and then we have the line. So, all good.